let's talk about the tangent ratio. The tangent ratio is often the start of a unit called trigonometry. And the tangent ratio stands for the tangent of an angle, which means that we're looking at the opposite side divided by the adjacent side, the TOA part of SOHCAHTOA, a mnemonic used to help learn trigonometry. It's really important that you have a scientific calculator with this video so that you can follow along and type the buttons in as we go. So first let's start with asking about what do you notice? Well, hopefully you notice a bunch of right triangles. Hopefully you notice that they're isosceles right triangles because the two legs of each of these triangles have tick marks, meaning that they're the same. And hopefully you know from your special right triangle study that if the legs are the same, the base angles have to be the same. So these are 45, 45, 90 right triangles. They're special right triangles. If a leg is 3, the other leg is 3, and the hypotenuse has to be 3 square roots 2. 4, 4, 4 square roots 2. 5, 5, 5 square roots of 2, 7, 7, 7 square roots of 2, and 10, 10, 10 square roots of 2. What do you notice about the ratio of the opposite leg over the adjacent leg? Well, for either of the two 45-degree angles, let's talk about angle B. The opposite leg is the 3, the adjacent leg is the other 3, and 3 divided by 3 is 1. 4 divided by 4 is 1, 5 divided by 5 is 1, 7 divided by 7 is 1, 10 divided by 10 is 1. You have just learned that the tangent of a 45-degree angle is 1. So let's verify that on a calculator. I'd like you to press the tan button. Tan is the abbreviation for tangent. And then press 45. And then you can close your parentheses or you can simply press enter. And you should see that the tangent of 45 degrees is 1. If you don't see a 1, it's highly likely that your calculator is not in degree mode and you will need to change it to degree mode so that you can verify that the tangent of 45 is 1. So we're going to use the tangent ratio to answer questions like, how tall is this tree? When you have things that you aren't able to measure directly, that's where trigonometry can come into play. And it's the very powerful tool that we can use to measure all sorts of things indirectly or calculate all sorts of things indirectly. So the tangent ratio is defined to be the length of an opposite leg of an angle divided by the length of the adjacent leg to that angle in a right triangle. So when a right triangle has an acute angle A, the length of the opposite side divided by the length of the adjacent side is going to be defined as the tangent of that angle. So it's really crucial that you understand how to find the opposite leg and the adjacent leg. The opposite leg is across from the angle, much like the hypotenuse is across the triangle from the right angle, and the adjacent leg is the leg that helps form the angle along with the hypotenuse. So hypotenuse and adjacent make the angle. The opposite leg is far away from, across from, opposite that angle. So let's try it out. We're going to find the tangent of angle A and the tangent of angle B. And that tangent value, that ratio of the opposite over the adjacent, will change depending on which angle you're referencing. So we'll start by referencing angle A. Put our finger on angle A, a pencil on angle A, and when we want to find the tangent of that angle, we need to find the opposite side and divide it by the adjacent side. The opposite side of angle A, well, it helps to first label the hypotenuse if necessary, and the hypotenuse and the adjacent side make the angle, so the remaining side has to be the opposite side. So the tangent of angle A is opposite over hypotenuse, opposite divided by adjacent, 12 divided by 16. And that reduces to 3/4. Simplifies to 3/4. So if you don't know how to simplify and you want to use your calculator, want to learn some new buttons, most calculators have an ABC button or a numerator over denominator button, or sometimes it's simply a box over a box. The ABC button often looks like A, B over C. And so when you type 12 and then you type that numerator, denominator, or ABC button, you'll get to the denominator, and then you can type the 16. And when you type 16, not 18 in my example, I'm sorry, you will get 3/4, unlike this 2/3 that I have. So 12/16 is 3/4. Our example asked us to round the answer to 2 decimal places. If we take 3 divided by 4 on our calculator, we will get 0.75. 0.75. So let's also find the tangent of angle B to 2 decimal places. So angle B is this angle up here. The hypotenuse is still the 20, but this time the hypotenuse and side BC create this angle. So side BC is our adjacent, and the opposite is far away from angle B, so it's the 16. So when we want the tangent of angle B, we want the opposite divided by the adjacent, the 16 divided by the 12, and when we simplify that, we get 4/3. We like to write our fraction as an improper fraction. We prefer, most cases, to have it as a fraction, not as a mixed number and not as a decimal, but the directions here say to give it to your answer to 2 decimal places. So if you divided it out, you would have 1.333 repeating. The third 3 would not make the second one change to a 4, so we'd simplify or leave it as simply 1.33. All right, so to understand where these ratios come from, we can go to a GeoGebra app. And so if we look at this app, we can see that we can choose any angle we prefer. So as we move our angles back and forth, we can make a 45-degree angle if we'd like. And we can show that we have a 9/9, our opposite over our adjacent is 1, just like we saw earlier. But we can also change it so that we have a 30-degree angle or a 25-degree angle. And watch what happens to our opposite over adjacent leg as we move point B to enlarge our triangle or to shrink our triangle. Our short leg divided by our long leg is always 0.577. 0.577. So let's try to make our short leg a nice number, like 3, something close to 3. We should know from our special right triangles that if the short leg is 3, then the long leg is 3 square roots of 3, which is about 5.2. And when we divide them out, we always get the same ratio because these are similar triangles. So the opposite over the adjacent should always be the same number. If we change it to a 20-degree angle, we're always 0.364 to 3 decimal places. Pick a 15-degree angle or a 10-degree angle. That opposite over adjacent is always the same. So that's where these numbers, these ratios come from. And these ratios are stored in a table on your calculator. So here's a table from NASA that shows the tangent ratios or the tangent angles, tangents for the angles, 0 through 90 in a 1-degree increment to 4 decimal places. So make sure your calculator is in degree mode. I'd like you to type tangent of 12. And you should get something close to 0.2126 if I round to 4 decimal places. 0.212556562. Okay? Again, if you don't get that result, make sure that your calculator is changed to degree mode, not radian or gradian. Next, we're going to type the tangent of 77 degrees. So when you type tangent 77 and you press enter or return, you should get 4.3315. So 4.331475874 is the answer to, I believe, 9 decimal places. Okay, so those are stored in your calculator and they're in memory. You don't have to worry about trying to come up with these values, but let's ask ourselves if this makes sense. If we had a 77-degree angle, does it make sense that the ratio of the opposite side divided by the adjacent side would be more than 4 times as big? Well, here's a 77-degree angle. Does it look like this side is 4 times or more larger than this one? Absolutely. So now we need to set up equations and solve for the value of x. So if we look at our right triangle, and again, tangent only works for right triangles, we have an angle that's been given to us. We have a side that's been given to us, and we're trying to find another leg. So the hypotenuse is not being worked with today. It's opposite the 90-degree angle, so we don't have to worry about the hypotenuse. But from this angle, which side is adjacent to this angle? Which side helps to make the angle along with the hypotenuse? That is the 12. The 12 is the adjacent. The side that is labeled with x is the opposite. So when we want the tangent of our angle, we're taking the opposite divided by the adjacent. TOA stands for opposite over adjacent. So the tangent of the angle, 67 degrees, is going to be equal to x divided by 12. Now students get excited when they see a 67-degree angle and want to press tangent 67 on their calculator right away. But it's really important that you set up the equation first and then you solve that equation. So when you set up that equation, we see that we have a tangent of 67 is equal to x over 12. Well, that over 12 means divide. So we want to do the opposite of division, which means that we're going to multiply both sides by 12. And that simplifies to x is equal to 12 times the tangent of 67. So on our calculator, we're going to type 12 times the tangent of 67, and we should get 28.27. This says to the nearest tenths place, so we want to round to the first decimal point. The 7 will make the 2 a 3, so it's 28.3. Ask yourself if that's reasonable. Based on our drawing, with this amount being 12, does it look like this could be 28? Yes, it looks more than twice as big. Now, what happens is students get excited and want to start typing in their values, and they don't solve for x first. So a common mistake I've seen is that students will type tangent of 67, and then they want to take that times 12. Well, if they simply type tangent of 67 times 12 and press enter, they will get 9.51, so 9.5 to 1 decimal place. If they stop themselves and ask themselves does this look like it could be 9.5 when the other shorter side is 12, they would realize that they've made a mistake. What your calculator does, because it's scientific and because it understands the order of operations, is it multiplies the 67 degrees by 12 first, and then it evaluates the tangent of that angle. So to avoid that, either type your side in and then multiply it by the tangent of 67 first, or when you're typing the tangent of 67 in first, make sure that you close your parentheses before multiplying by 12, and then you'll get the 28.3 that we got earlier. All right, next example. So we have a 34-degree angle this time, and we need to find the value of x. Well, x, once again, is the opposite side of that 34-degree angle, and 18 is the adjacent side to the angle. So the tangent of 34 degrees, our angle always goes with tangent, it's a tangent of an angle, equals a side over a side, an opposite side divided by an adjacent side. So once again, x is being divided by 18. Inverse operation is multiply. We multiply both sides by 18. And x becomes 18 times the tangent of 34. So when we type the tangent of 34 times 18, being sure to close our parentheses, or 18 times the tangent of 34, we should get 12.14. The 4 does not round the 1 up to a 2, so our opposite side should be 12.1. And we take a quick peek. Does this seem possible that this would be 12.1 if this is 18? And it appears that that is a good answer. All right, one more example of this type of problem. We now have a 27-degree angle, and the hypotenuse is the longest side of our triangle. The adjacent helps make that 27-degree angle, and so x is the adjacent, and 16 is the opposite. So tangent, once again, says take the tangent of the angle and set it equal to the opposite divided by the adjacent. This time, the tangent of 27 is being divided by 16 is being divided by the tangent of 27. So we need to do some extra work here rather than simply multiplying by 16 by the tangent of 27. So let's put tangent of 27 over 1 to make a fraction equal to a fraction. Now, because we've done so much work with cross products, we can say that x times the tangent of 27 is going to be equal to 16 times 1. And if x is being multiplied by the tangent of 27, we divide by the tangent of 27 to get x. So on our calculator, we're going to type 16 divided by tangent of 27, and we should get our answer. And our answer is 31.4 to the nearest tenth. The 0 does not make the 4 become a 5. So our adjacent, or our x, is 31.4. Once again, checking our triangle, if this is 16, does it seem possible that this side would be 34.1? And it looks like it's about double in length. So, using the special right triangle below, we want to see if we can find the exact value of the tangent of 30 degrees. So exact value means that we don't want to stop at 9 decimal places. We don't want to plug this straight into the calculator. We want to find the exact value, meaning keep square roots in there if necessary, and see what it evaluate to. So pick your favorite number. Doesn't matter what number it is. Maybe your favorite number is 4. If your favorite number is 4, let's let that be the short side of our special right triangle, our 30, 60, 90 triangle. And so if the short side, the short leg is 4, when we want to find the hypotenuse, we take it times 2 to get 8. And when we want to find the long leg, we take it times the square root of 3 to get 4 square roots of 3. This 30-degree angle has a hypotenuse that is 8 and an adjacent leg that is 4 square roots of 3. And an opposite leg that is our 4. So if I want the tangent of 30 degrees, I'm going to take the opposite divided by the adjacent. Opposite is 4. Adjacent is 4 square roots of 3. 4 over 4 simplifies to 1 over the square root of 3. And since we don't like to leave a radical in the denominator, we rationalize that by multiplying by the square root of 3 over the square root of 3. And we get the square root of 3 over 3. The square root of 3 times itself is plain old 3. And that is the exact value of the tangent of 30. Would it have mattered had we taken a different approach and chosen a different number? Maybe our favorite number is 20. If our short leg is 20, our long leg is 20 square roots of 3. Would we get a different result if we had taken 20 divided by 20 square roots of 3? Absolutely not. It's still the square root of 3 over 3. Because they're all similar triangles, they scale up, they scale down, but their fundamental value is the square root of 3 over 3. All right, remember that the angle of depression is the angle seen when you're at the top of something looking downward. The angle of elevation is found when you're looking up from a location to something higher. So if an airplane is flying at a height of 3 miles above the ground, and the angle of depression from the airplane to the airport is 2.5 degrees, you can calculate the ground distance from the airplane to the airport. Helps to have a visual. And this visual is not to scale. This is certainly not a 2.5 degree angle, but it's what I had a space to work with. So we have an angle of depression that's 2.5 degrees. And the height of the airplane above the ground is 3 miles. So we want to find the distance, the ground distance, from the airplane to the airport. Well, this ground distance should be the same as this ground distance. Parallel lines, they have the same distance. So if this is our angle, and the hypotenuse is the longest side of our right triangle, the adjacent side is along with the hypotenuse helps form the angle, so the x is the adjacent and 3 miles is the opposite. And so when we want to find the tangent of this angle, the tangent of 2.5 degrees is going to be equal to the opposite divided by the adjacent. So 3 divided by x. If we put a 1 below and we cross multiply, x times the tangent of 2.5 degrees is equal to 3 times 1. Divide both sides by the tangent of 2.5 to get the x by itself. And x will be equal to 3 divided by the tangent of 2.5. How tall is the tree? So we started with a question. If we're looking up at a tree, is there any way we can determine what the height of that tree is without trying to climb the tree and drop a measuring device and so forth? Well, if you notice, I'm standing down here by this tree, and I'm almost eye level with the tree. And I have a protractor, an angle ruler actually, that I'm using to sight the top of the tree. So I measured how far I was away from the base of the tree, and my tape measure was 16 feet. I had to use 3 versions, or had to stretch it out 3 times over, so I was 48 feet away from the base of the tree. When I used my angle protractor, or my angle ruler, I sighted it using a smoothie straw, and it was a 59-degree angle from where I was standing 48 feet away. So if we have a 59-degree angle and a right triangle, because the tree hopefully grew vertically, and I'm trying to find the height of the tree, I'm trying to find the opposite side of the tree, and I have the adjacent side, my 48 feet that I measured. So because it's opposite and adjacent, we can use the tangent of that angle, and that's going to be equal to the opposite side divided by the adjacent side. Because x is being divided by 48, we want to do the opposite, which is multiply by 48. So if you take 48 feet times the tangent of 59, you'll find out exactly how tall that tree was.